Welcome to our video on 15 mind-bending facts about black holes. Black holes are some of the most mysterious and fascinating objects in the universe, and they have many strange properties that make them truly unique. 1. Black holes can be found in the center of most galaxies, including our own Milky Way. Scientists have discovered that many galaxies, including our own Milky Way, have a supermassive black hole at their center. These black holes can have masses that are millions to billions of times that of the Sun. The presence of a supermassive black hole at the center of a galaxy is thought to be related to the formation and evolution of the galaxy. The supermassive black hole at the center of the Milky Way, called Sagittarius A star, has a mass of around 4 million times that of the Sun and is located about 26,000 light-years away from Earth. Scientists have been able to observe its effects on nearby stars and gas clouds, and have even been able to take images of its shadow, using the Event Horizon Telescope. The discovery of supermassive black holes at the centers of galaxies has led to many questions and ongoing research about their properties and effects on their host galaxy. 2. Black holes are incredibly dense. A black hole with the mass of the Sun would be smaller than the city of San Francisco. Black holes are super-dense objects, with a very high mass-to-size ratio. This means that even though they can have masses that are millions to billions of times that of the Sun, they can be surprisingly small in size. The size of a black hole is determined by its event horizon, which is the point of no return for anything that gets too close to the black hole. The event horizon is also known as the Schwarzschild radius, and is directly proportional to the mass of the black hole. For a black hole with the mass of the Sun, the event horizon would be about 3 kilometers, 1.9 miles, across, which is smaller than the city of San Francisco. A black hole with the mass of the Sun would be incredibly dense, with a density of around 2 times 10 to the 17 kilograms per cubic meter. To put that in perspective, the density of a neutron star is around 2 times 10 to the 17 kilograms per cubic meter, and the density of an atomic nucleus is around 2 times 10 to the 14 kilograms per cubic meter. It is worth noting that black holes come in different sizes. The supermassive black holes that are located at the center of most galaxies can have masses that are millions to billions of times that of the Sun, and their size can be equivalent to the solar system. 3. Black holes can merge with each other to form even larger black holes. This process is called a black hole merger, and it occurs when two or more black holes come into close proximity and their gravity causes them to spiral toward each other and eventually merge into one larger black hole. Black hole mergers can happen in many ways. One way is when two black holes are in a binary system, where they orbit each other. Over time, the two black holes will lose energy through the emission of gravitational waves, which will cause them to spiral closer and closer together until they eventually merge. Another way that black holes can merge is when two galaxies collide and merge. The collision of two galaxies can bring their central black holes into close proximity, causing them to merge. This can happen in a galaxy cluster when two galaxies collide and merge. Black hole mergers are incredibly powerful events, and they can release enormous amounts of energy in the form of gravitational waves. These waves can travel through space and can be detected by gravitational wave observatories such as LIGO and Virgo. 4. The event horizon is the point of no return for anything that gets too close to a black hole. The event horizon is the boundary around a black hole beyond which nothing, including light, can escape. It is also known as the point of no return, because once an object crosses the event horizon, it is inevitably pulled towards the black hole's singularity, which is a point of infinite density and gravity. The event horizon is defined by a specific distance from the black hole called the Schwarzschild radius. This radius is directly proportional to the mass of the black hole, and it is the distance at which the escape velocity exceeds the speed of light. Since nothing can travel faster than the speed of light, anything that crosses the event horizon is unable to escape the black hole's gravitational pull. Anything that comes too close to the event horizon will experience the effect of time dilation. Time will appear to slow down from the outside perspective. Also, the black hole will appear to be distorted and the light from the object will appear to be stretched. It is worth mentioning that not all black holes are the same. Some of them have a charge and/or rotation. Those black holes have a different event horizon, called the ergosphere, which is the outer edge of the black hole where the gravity is so strong that it can pull objects along with it as it rotates. 5. Black holes can create intense radiation and even warp spacetime. Black holes are known for their incredibly strong gravitational pull, which is so strong that nothing can escape from it, including light. However, black holes also have other effects on the surrounding matter and spacetime. One of the effects of a black hole's gravity is the creation of intense radiation. The intense gravity causes the surrounding matter to heat up and emit radiation, which is called Hawking radiation. This radiation is caused by the quantum effects of the black hole's event horizon and is named after Stephen Hawking, who first proposed its existence. However, this radiation is incredibly weak, and it is not enough to be detected from a black hole that is located a few light-years away from Earth. Another effect of a black hole's gravity is the warping of spacetime. Black holes are so massive and dense that they can bend the fabric of spacetime around them, causing it to warp and stretch. This effect is known as gravitational lensing and can be observed when a black hole's gravity bends the light from a distant object, making it appear distorted or even creating multiple images of the same object. The warping of spacetime also causes the black hole to have an effect on the orbits of nearby objects. This effect is called the frame dragging effect. It causes nearby objects to rotate along with the black hole. This was first predicted by Einstein's theory of general relativity and later on observed. 6. Some scientists believe that black holes may be connected to the origins of the universe. Some scientists believe this theory because of the properties and effects the black holes have on matter and spacetime. One theory is that black holes could have played a role in the formation of the first stars and galaxies. It is thought that the intense radiation emitted by black holes in the early universe could have helped to cool and collapse gas clouds, leading to the formation of the first stars and galaxies. Another theory is that black holes could be the remnants of the first massive objects to form in the universe, known as primordial black holes. These black holes could have formed from the extreme density fluctuations in the very early universe, just moments after the Big Bang. There is also a theory that suggests that black holes could be connected to the creation of the universe itself. The theory of cosmic inflation proposes that the universe went through a period of extremely rapid expansion in the early moments after the Big Bang, and it suggests that black holes could have formed during this period. 7. Black holes can be classified into three main types based on their mass: stellar, intermediate, and supermassive. Stellar black holes are the most common type of black hole and are formed when a massive star dies and its core collapses. They have masses that range from a few to tens of times the mass of the Sun. Intermediate black holes are a recently discovered class of black holes that have masses that range from 100 to 100,000 times the mass of the Sun. These black holes are thought to form from the mergers of multiple stellar black holes or from the collapse of massive clusters of stars. Supermassive black holes are the most massive type of black hole and are found at the center of most galaxies, including our own Milky Way. These black holes have masses that range from millions to billions of times the mass of the Sun. It is worth noting that not all black holes fit perfectly into these categories. There are also intermediate mass black holes, IMBH, with a mass between 100–100,000 solar masses, and mini black holes that are smaller than stellar black holes and could have formed from other processes in the early universe. 8. The closest known black hole to Earth is located in the constellation Cygnus, about 1,500 light-years away. This black hole is called Cygnus X1. It is located about 1,500 light-years away from Earth and is part of a binary system, where it orbits a blue supergiant star. Cygnus X1 was first discovered in 1964 by a team of scientists who were studying X-ray sources in the sky. They noticed that one of the X-ray sources, known as Cygnus X1, had a companion star, and they determined that the companion star was in orbit around a very massive object. Based on the orbital period and the mass of the companion star, they inferred that the massive object was a black hole. Since then, Cygnus X-1 has been studied extensively, and it is now considered to be one of the best-studied black holes in the universe. Scientists have been able to observe its effects on the companion star, such as the intense radiation and the warping of spacetime, and have been able to determine that it has a mass of about 14 times that of the Sun. Cygnus X-1 is also notable because it was one of the first black hole candidates, and its discovery helped to establish the existence of black holes. 9. Black hole can actually evaporate over time due to a phenomenon known as Hawking radiation. Black holes are known for their incredibly strong gravitational pull, which is so strong that nothing, including light, can escape from it. However, according to the laws of quantum mechanics, black holes are not completely black. They can actually emit radiation. This radiation is called Hawking radiation, named after physicist Stephen Hawking, who first proposed its existence in 1974. Hawking radiation is caused by the quantum effects of the black hole's event horizon. According to quantum mechanics, particles are constantly popping in and out of existence in empty space. These particles, known as virtual particles, can be created in pairs, one with positive energy and one with negative energy. Near the event horizon of a black hole, one of the virtual particles can be pulled into the black hole, while the other escapes. The particle that escapes is what we observe as Hawking radiation. The radiation is extremely weak, and it is not enough to be detected from a black hole that is located a few light-years away from Earth. However, over very long periods of time, the black hole will lose mass through the emission of Hawking radiation, causing it to evaporate slowly. This process is known as Hawking evaporation. It is worth noting that the rate of evaporation depends on the size of the black hole. Smaller black holes will evaporate faster than larger ones. The rate is also extremely slow, and it would take billions of years for a stellar black hole to evaporate. Supermassive black holes are not expected to evaporate in the lifetime of the universe. 10. Black hole can have a shadow, due to the bending of light around it. Black holes are incredibly dense and massive objects that are created by the collapse of massive stars. They are so dense that their gravity is so strong that nothing can escape from it, including light. This is what gives them their name, as they appear as black objects in space. However, black holes can have a shadow, due to the bending of light around them. When light passes close to a black hole, it is bent and distorted by the strong gravitational field of the black hole. This effect is known as gravitational lensing, and it causes the light to bend around the black hole, creating a dark region in the sky known as the black hole's shadow. The shape and size of the shadow depend on the properties of the black hole, such as its mass, charge, and rotation. For non-rotating uncharged black holes, the shadow is circular, but for rotating black holes or black holes with charge, the shadow will be distorted and elongated. The study of black holes' shadow is an active area of research, and scientists have been able to observe the shadow of the supermassive black hole at the center of the galaxy M87, using the Event Horizon Telescope, EHT, a network of telescopes that combine to form a virtual telescope the size of the Earth. This was a major breakthrough in the study of black holes, and it allowed scientists to test some of the predictions of Einstein's theory of general relativity. 11. Scientists have observed black holes that rotate at incredibly high speeds, approaching the speed of light. These are known as fast-rotating, or extreme spin, black holes. A black hole's spin is determined by the angular momentum of the material that collapsed to form the black hole. In most cases, the angular momentum of the material is relatively low, leading to black holes that rotate at moderate speeds. However, in some cases, the material that collapses to form a black hole can have very high angular momentum, leading to black holes that rotate at extreme speeds. Fast-rotating black holes have some distinct properties compared to non-rotating or slow-rotating black holes. The event horizon, the boundary beyond which nothing can escape, is distorted by the rotation, and it becomes oblate, meaning it is flattened at the poles and bulging at the equator. The frame dragging effect, which is the effect on nearby objects' orbits due to the rotation of the black hole, is also much more pronounced. The detection of fast-rotating black holes is challenging, but scientists have been able to detect them using X-ray observations, by measuring the X-ray emissions from the hot gas that is swirling around the black hole and by the gravitational waves that are emitted when two black holes merge. 12. Some black holes are surrounded by swirling disks of gas and dust called accretion disks. Since black holes are incredibly dense and massive objects, they have such a strong gravitational pull that anything that comes close to it, including gas and dust, will be pulled in and eventually be swallowed by the black hole. However, before the material is swallowed, it forms a swirling disk of gas and dust around the black hole, known as an accretion disk. Accretion disks are formed when material, such as gas and dust, falls toward the black hole. As the material approaches the black hole, it is pulled in by the strong gravitational force. However, the material also has angular momentum, which causes it to move in a curved path around the black hole, forming a disk. The material continues to spiral inwards, towards the black hole, but it also orbits the black hole in the disk. The material in the accretion disk heats up due to friction and compression as it orbits the black hole. This causes the disk to emit light, X-rays, and other forms of radiation, making it visible to telescopes. Accretion disks are a common feature around black holes, particularly around supermassive black holes located at the center of galaxies, and around stellar mass black holes. They are also found around other compact objects such as neutron stars. 13. Scientists have observed black holes that emit powerful jets of particles, known as black hole jets. These particle jets are composed of high-energy particles, such as protons and electrons, that are ejected from the vicinity of the black hole at nearly the speed of light. Black hole jets are formed when material falls into a black hole and forms an accretion disk around it. The accretion disk is extremely hot and generates a magnetic field. As the material in the accretion disk orbits the black hole, the magnetic field lines get twisted and distorted. This generates intense electric currents, which accelerate particles in the disk to high energies. These particles are then propelled outwards along the magnetic field lines, creating powerful jets of high-energy particles. Black hole jets are observed in many different types of systems, including active galactic nuclei, AGN, gamma-ray bursts, GRBs, and microquasars. They are also thought to be responsible for many of the high-energy phenomena observed in these systems, such as X-ray and gamma-ray emissions. 14. Some scientists believe that black holes may be connected to other dimensions or parallel universes. Some scientists have proposed this idea based on the concept of a black hole as a wormhole, which is a tunnel-like structure that connects two distant points in spacetime, or even different universes. One theory is that when a black hole forms, it creates a wormhole, connecting the inside of the black hole to another point in spacetime or even a parallel universe. According to this theory, anything that enters a black hole would pass through the wormhole and end up in another universe. Another theory is that black holes are baby universes, which form inside a larger universe. According to this theory, black holes could be the birthplaces of new universes. It is worth noting that these theories are still in the realm of speculations and theoretical physics, and it's hard to prove or disprove them. There is no observational evidence to support these ideas and no known way to test them. 15. It is thought that black holes may be the key to understanding the ultimate fate of the universe. This is because they are the most extreme and mysterious objects in the universe. They are extremely dense and have a gravitational pull so strong that nothing can escape from them, not even light. Black holes are also thought to be connected to some of the most fundamental questions about the universe, such as the nature of space and time, the behavior of matter and energy, and the origins of the universe. One of the theories is that black holes could play a role in the ultimate fate of the universe by acting as a sink for matter and energy. According to this theory, as the universe continues to expand, it will eventually become too diffuse to support the formation of new stars, and the existing ones will exhaust their fuel and die. As a result, the universe will become dark and cold. Black holes will be the only objects that will continue to exist, and all matter and energy will eventually fall into them. Another theory is that black holes could play a role in the ultimate fate of the universe by acting as a portal to other universes. This is based on the idea that black holes could be wormholes that connect our universe to other dimensions or parallel universes. According to this theory, as the universe continues to expand, it will eventually become too diffuse to support the formation of new stars and galaxies. Black holes will be the only objects that will continue to exist, and all matter and energy will eventually pass through the wormholes and into other universes. These are just a few of the weird facts about black holes. We hope you enjoyed learning about these unique objects and the mysteries they hold. Thank you for watching. Don't forget to like, share and subscribe to our channel for more interesting facts and videos.